I greet you, highly esteemed viewers. Welcome to this video on technical drawing with Teacher Dixon. And today's lesson, we want to still continue on the development that has to do with parallel lines development. Remember, we made mention of the fact that parallel lines development have to do with prisms and cylinders. All right, in our today's lesson, we want to consider the development of the frustum of a cylinder. Now, a cylinder, as we've all known, is a three-dimensional shape, a solid that has round faces and curved sides. Right. So if we are talking about a frustum of a cylinder, it means that the upside might have been cut off. Sometimes we can refer to it as a truncated cylinder. All right. So to start drawing that or constructing or developing this, we'll have to draw the circular plan. So we'll have the plan. We have three diagrams to produce: the plan, the front view, and then the development. Now what you see me do right now is the plan. I am drawing a circle and about to divide the circle into 12 equal parts. You're just to take a look at the steps that I'm taking. Now I am ensuring that my set square sits squarely on the T-square while I draw the vertical diameter. And I tilt my set square. I'm trying to draw my T-square towards where I'll have the center. Okay, so I'm drawing the horizontal line first after I might have drawn the vertical line. So the horizontal diameter is drawn as well. Now I am drawing an inclined line which still gives me a diameter at 30 degrees. And alternately, I am equally drawing the next diameter, still in the division of the circle into 12 equal parts. Now I'm using 60 degrees angle to draw the next diameter, and alternately I am trying to turn the T-square to give me the alternate sides of the 60 degrees. Every line has to pass through the center of the circle to have the division the way it is expected. As you can see, I've divided the circle using only 60 and 30 degrees set square to 12 equal parts. Next thing I'm to do is to number. So I've got a 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, then 11 and 12. So I have divided my circle into 12 equal parts. Okay, so I've just fixed a point so as to start drawing the front elevation. I am drawing the length of the line to be able to capture even the development when I'll be considering that. But for now, the baseline you're seeing there, the horizontal line, is meant for the front view. So I'm going to project lines from the upper side of the circle to meet and pass the horizontal front view line that has been drawn. Okay, so at every point that I locate on the circumference of the circle, I have to project line to the front elevation. That is what I am doing. I intend having the front view of the frustum of the cylinder we are expecting. All right. So as it stands, I have projected the lines upwards. Okay. Now at this point, we would like to take the height of the front view, but before that we are trying to extend the length of the line, since we are using a short set square, so that it will help us to get the height of the frustum of the cylinder we are expected to draw. Okay, having extended the line, the next thing we have to do here is to take the height from the right hand side of the front view, and we are taking 3 cm. Okay, then we will use 60 degrees to draw the inclined surface of the frustum of the cylinder where it is cut. So we are making that at 60 degrees. That is not a rule. It can be made maybe 45, can be any other angle, but this is what we want to use at this point. Now we are retracing the front view so as to make it lucid, so that somebody will see, like it be clear, right, so that we will not mistake other construction lines to the original front view. Right, we've achieved that. We've drawn both the front view and the plan. The next thing to be done now is to produce the expected development. And at this point, the next step to be considered is a vertical line linking the baseline already drawn, the horizontal one, after leaving a gap. Now we are marking off, we are taking measurement of one of the divisions on the plan. Remember, we divided the plan into 12 equal parts. Now we are using a pair of compass to take one part of the division. It could be any one, like from 1 to 2, 3 to 4, 5 to 6, however. Then we are marking off the divisions on the straight horizontal line that we're using to produce the development. So here we do that. We're going to mark off just as hard on the circumference of the circle. We're going to mark off 12 equal parts, equal divisions. So we are in the process. We're marking off using a pair of compass. All right, you will permit us if the thing crosses the borderline. It is expected, since we are looking at 12 divisions. All right. Okay. So we are given the numbers beginning from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is what we're doing at this point. Okay. So take a look at that. We've gotten to the 12th position. Now the next thing to be done, the next step is to erect perpendicular lines. Erect perpendicular lines on each of the marked positions from 1 to 12. We are erecting perpendicular lines. When we say perpendicular line, a perpendicular line is a line that is drawn at right angle, that is at 90 degrees to another line. Right. So we had already gotten a horizontal line, so we'll have to draw vertical lines at 90 degrees to that, giving us the perpendicular lines we're talking about. All right, so we are in the process of getting our vertical line, or call them perpendicular lines, ensuring that our development will be neatly produced. Now, bear this in mind, developments are meant to be drawn and carved out, traced out. So, after drawing everything, after constructing, or however you want to put it, you will have to carve your development part out to obtain whatever solid object, a 3D object you were expected or you are in mind to produce. So whatever you do has to be accurate enough to meet the requirements. So at this juncture, we've erected the 12 perpendicular lines. The next thing we are to do is to follow these points on the slant surface of the frustum to draw horizontal lines meeting the vertical lines on the development parts. So we are drawing horizontal line following each of the points of intersection between the vertical lines that came from the front view meeting the slanted line on the front elevation. I mean the ones that came from the plan meeting the slant line on the front view. Okay, so we are transferring the point of intersections to the development part. That's what we're doing. All the lines need to be drawn neatly. That's why we are stocking our T-square very well, and then we're using that to draw. At this point, we finished drawing that. The next thing we are going to do to obtain the development is to highlight the point on the development where it is shown. All right. Okay, so we are going to follow the pointed areas, and then we'll highlight those points first before we go to the slant surface and see how it is going to look like. All right, so we're making use of the 60-degree and 30-degree set square to highlight that point. Okay, we've just highlighted the left-hand side, and we are moving towards the right-hand side to highlight as well. We've had that highlighted already. Okay. So we are equally highlighting the baseline on the development surface. Having done that, the next thing we will want to take a look at is to match each of the points using our meter rule. That's our ruler. Matching the points of intersection on the graphical locations, right? Where you have it look like graph, we're matching the points so as to have the slant surface of the truncated cylinder or frustum of a cylinder. So that is the face we are trying to produce now. I am ensuring that the lines are thickened at once so that we will not have to go back, since this is not a straight line. So we are producing that using thick continuous lines, which is expected to be a visible outline. Okay, so that is what we are getting right away. We've gotten that to the apex of the curve, and we want to get to the next. Point 6 should be the highest point of that. If you check the plan, you will notice that point 6 on the plan has the highest location on the front elevation. So that is why, by implication, it equally has the highest point on the development surface. Right, so we are still matching each of the individual points to get our development. So even when we are using a meter rule to draw the line, you agree with me that you're having a curve there, right? But the best thing to have been done, since we are developing what do we call? Since we're developing a cylinder, would have used a French curve, but for the purpose of trying to be quick in locating the points, but still is giving us a curved surface there. So this is the development of the frustum of a cylinder. We've gotten it. Now what we expected to do right now, what we are trying to fix now, we are looking at point 9 on the baseline, and we are transferring the radius of the plan to have a circular surface there, so as to give us the curved surface or the curved base of the cylinder, right? Such that when you fold it, after you might have carved out, you will cover the downside, the base, while the frustum, the cut part, will remain open. Now in our next video, we will try to see how we can produce the true length of the cover that should suit this frustum of a cylinder. That's what we'll do. Now I'm retracing the circle so as to make it seen, to make it clear and obvious enough to the eye, right? So at this juncture, I'd like to let you know that we've been able to successfully produce the frustum of a cylinder we were asked to produce. I look at it. Those places that were pointed are the